right. Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be going over Unit 1, Notes 6. So we are going to be talking about the distance formula. Now, the distance formula you partly did in algebra. We're going to take it a couple steps further today, and we're going to actually apply it to geometry. So let's go ahead and let's just take a look at very, very basic distance between 2 points, and that is distance between points on a number line, so only one coordinate. So to find the distance between the number line, you're just going to subtract. Okay, so what I'm going to do is I'm going to take what's on the farthest right, which is C, so that's 0, and I'm going to subtract what's on the farthest left, which here is A. Now here I'm subtracting a negative, so that's going to become plus a positive. So it's going to be the absolute value of 0 plus 5, which is just going to be 5. Remember the absolute value, it's going to take any number and it's going to make it positive. So then for B, D, we have B and we have D. So D is the farthest right. I'm going to take that and I'm going to subtract off B. So again, subtracting a negative becomes plus a positive. So then I'm going to have the absolute value of 4, and the absolute value of 4 is just 4. Last but not least, let's go ahead and let's take a look at AD. So then I'm going to take the farthest left, which is 2, and I'm going to subtract off, take the farthest right, which is 2, and subtract off the farthest left, which is 5. So that's going to become plus a positive. And then I'm going to get the absolute value of 7. Well, the absolute value of 7 is simply just 7. So that's my answer for number 3. So that's all it is when you're looking at a number line. It's really just simple subtraction. So let's go ahead now and let's just take a look at the distance formula in general. You're going to want to have this written down because you're going to want to have access to it on any quizzes that we may take. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1. So these numbers are coming from here. We have a point x1, y1, and we have a point x2, y2, and then we're going to plug those numbers in. So that's what those letters mean, is they are tying to a number. So let's go ahead and let's take a look of an example of that. So I'm going to let this one over here, I'm going to call this one x1, this one y1, this one x2, this one y2. So now I'm going to go ahead and plug that into the formula. Okay, so I have y2 minus y1, subtracting a negative becomes plus a positive, plus x2, come on. Oh, anybody want to type? Can you tell I'm still getting used to this app? Because I sure am. x2 minus x1, again, subtracting a negative becomes plus a positive, okay? So then what we're going to do is we're going to add those up. So negative 1 plus 6, well, that's going to give me 5. 5 plus 4 is going to give me 9. And if you had these two flip-flopped around, that's okay. It still means the same thing because addition, the order doesn't really matter. So then I'm going to get the square root of 25 plus 81. So I just went through and squared those. And that's going to give me the square root of 106. Now, when we did algebra, I was mean and I made you break down the radical into pairs and all of that. Well, I'm not going to do that. For geometry, I actually want you to get a decimal approximation because we want to have an idea of what that means in actual distance. Okay, so the answer to that one is 10.3. And so now we're going to go ahead and we're going to calculate out the difference of this next one. So let's go ahead and let's take a look at number 5. So we need to assign x1, y1, and it actually doesn't matter. Apparently I'm drawing shapes now. As long as you keep the x1 in the same parenthesis as the y1. So let's go ahead and let's calculate that. So y2 minus y1 squared plus x2 minus x1 squared, subtracting a negative becomes plus a positive, and there we go. I wish that would stop. That's annoying. Okay, so then negative 4 minus 6. Now that actually is going to get more negative. So here I end up with a negative 10. Okay, and then 8 plus 5, okay, so that's going to become completely positive, and there I'm going to get 13. So now I'm going to go ahead and square those. Big thing to know, whenever you square a negative number, it should always, always, always come up positive. So be very careful about how you're entering that into your calculator. And then here, 13 squared is 169, so all of those are being added. So then I end up getting the square root of 269. So I do want you to actually square that in your calculator. And then you end up getting 16.40 as your answer. Okay. All right, taking a look now at number 6. Okay, so for number 6, what we need to do first is set it up to do the distance formula. So I'm going to assign my x1 and my y1. So I have x1, x1, y1, x2. Come on. And then y2. Apparently it doesn't want me to cross that x. All right, so then let's go ahead and let's calculate that out. So I have y2 minus y1, and then x2 minus x1. Okay, so again, when you're subtracting a negative, it's going to become more negative. So negative 7 minus 3 is actually going to be, oh, next page, a negative 10 squared. And then negative 3 minus 4, again, is going to become more negative, so you're going to get a negative 7 squared. Well, negative 10 squared is a positive 100. Again, squaring a number always makes it positive. Then we're going to add that 49. So then I end up getting the square root of 149, and I'm going to actually calculate that into a decimal, and that gives me 12.21. Something good to do is to be checking the calculations along with me to make sure you're doing it correctly. So let's find the distance between this one. So I have x1, y1, x2, y2. Let's go ahead and set that up in the distance formula. y2 minus y1 squared plus x2 minus x1. Subtracting a negative becomes plus a positive. So then negative 1 minus 1, that's going to get more negatives, so we get negative 2 squared. I don't know how that's supposed to be a 2. And then 3 plus 4 is 7 squared. So now I'm going to have 2 squared. Even though it's a negative 2, that's going to become a positive 4. And then 7 squared is 49. So I get 4 plus 49, and that's going to give me the square root of 53. So I'm going to actually calculate that out to a decimal, which is going to be 7.28. Okay, so now let's go ahead and let's take a look at number 8. So let's start by reading through this, okay? It says a certain helicopter can fly 450 miles before it needs to refuel. Okay, so that's probably going to be important, that 450 miles. Suppose a person needs to be flown from a helicopter in Minneapolis to one in Chicago. Chicago's 225 miles east and 175 miles south of Minneapolis. Can the helicopter make it? Well, let's go ahead and let's call Minneapolis the point 00, kind of like the origin. That's where we're starting from. And then we're going to go east and south, and that's Chicago. So it went east, so it went 225 miles east and 175 miles south. So I'm going to go ahead and call that negative. So now I can do the distance formula because I have x1, y1, x2, y2. So let's go ahead and do that. So I'm going to have the square root of y2 minus y1 squared plus x2 minus x1 squared. So since I'm subtracting off 0, it's really just negative 175 squared plus 225 squared. Now when I square that negative, remember it's going to become positive. So I'm going to have 5,062 plus 3,625. Okay, so then when I add those together, I end up getting 81,250. Then I take the square root of that, and I get 285 miles. So then I need to ask myself, is that less than the 450? Yes, it is. So it can make it the entire trip. Next, let's go ahead and let's take a look at this college campus problem. So on our college campus, Kelly has her first class in Rhodes Hall. Well, let's call Rhodes Hall 00. Okay, and her second class is in Fulton Lab. How far does she have to travel between her first and her second class? Okay, well, it looks like she goes 1/4 of a mile over and 1/8 of a mile over. So in order to figure out how much she goes over, we actually have to take 1/4 and we have to add 1/8 to it. So in order to do that, we need a common denominator. So I'm going to go ahead and multiply 1/4 by 2/2. So when I do that, I end up getting 2/8 plus 1/8, which is going to give me 3/8. Okay, so that's how far I went to the right. I went 3/8 to the right. Then it looks like she went south 3/8 of a mile. So I'm going to call that -3/8. So we have the point 0, 0, and we have the point 3/8, -3/8. So let's go ahead and let's do the distance formula with that. So I have x1, y1, and then this will be x2 and y2. It doesn't actually matter, again, that order. So I'll have y2 minus y1, that's going to become plus a positive, plus x2 minus x1. So then what I end up getting is the square root of 3/8 squared plus a -3/8 squared. So let's go ahead and let's square that. So then what we're going to have, 3/8 squared is 9/64. 3/8 squared again is 9/64. Okay, so then when we add that up, we get the square root of 18/64. Okay, so then I'm going to actually take the square root of 18/64, and I get 0.53 miles. So she actually walks a half a mile just over to class and back. So let's take a look at this. This is kind of where it starts to apply to some geometry for us. So an isosceles triangle has two sides of equal length. So that'll be really important to us eventually. Determine whether the triangle ABC with vertices A, -3, 4, B, 5, 2, and C, -1, 5. So what I need to do here is I need to actually calculate out the distance between each of these points. Okay, so let's start and calculate out the distance between A, B. Okay, so I'm going to have y2 minus y1, and then x2 minus x1, subtract a negative, becomes plus a positive. So then I end up getting -2 squared plus 8 squared. So that's going to be 4 plus 64. Okay, so that's going to give me the square root of 68, apparently in a highlighter. Okay, so now let's take a look at BC. So then when I do BC, y2 minus y1, and then x2 minus x1. And then we have -7 here, because when you do -5 minus 2, it's going to get more negative. 1 minus 5 is -4. So then that's going to -7 squared, remember, is going to become a positive 49. -4 squared is going to become a positive 4. So 49 plus 16 is going to give me the square root of 85. So last but not least, let's calculate out AC. So then when I calculate out AC, I get the square root of y2 minus y1 squared plus x2 minus x1. So that's going to become plus a positive. So then what we end up getting is the square root of 9 squared plus 4 squared. Okay, so then 9 squared is 81, 4 squared is 16. Add those together and you get the square root of 97. So since none of these are the same, it is not an isosceles triangle. Okay, so that concludes your note video for today. Thank you for listening.